All right, so I'm Josh, and we're going to be talking about data maturity models and decision science. So last year, I was asked to give a guest lecture for the MBA course for the University of Newcastle, and I was like, well, what do I talk about to them about data, and in particular my background's in consulting. So this is actually things Josh wish people knew better, so thanks for coming to my TED Talk. So it's a series of little things that I wish people knew about how to build effective data pipelines to make better decisions, and I've never really had a forum to be able to string together a lot of little things, so I'm trying to make a coherent narrative out of what are probably like 20 sub-talks. So I'll try my best to make it entertaining. So yes, as Anton mentioned, I have a background in software engineering. There was the Harvard Business Review article where it's like, data science, the sexiest job of the 20th century. So I did the postgrad data science and then realized there's no data science roles because everyone's like, hey, let's build a machine learning model. Can you deploy it? No. So everyone wants data engineers and machine learning engineers to do a lot of cloud-based stuff. So that's where most of the work is, and I'll talk about that. I've been in industry for about 15 years. If you look at my resume, I change jobs every 2 years, and I'm like, maybe I should go into consultancy so that way someone else is finding the job for me. And I've been doing that for about 2 years now. So I worked for a small startup consultancy firm which had about 50 people. Then we got acquired by Deloitte. So that's why I'm now part of Deloitte. But we're our own little independent group within Deloitte. So think of like Jim's Mowing sort of a franchise. Well, it's Jim's Data and AI. We are our own independent group. But the Data and AI group at Deloitte is like 800 people, which is like a whole series of other companies that have been acquired. So we're our own little group of 50 people. So I also know some stuff about AWS. Cool. So data maturity models, this is what we're going to get to. There was a report that came out that was a collaborative effort between Deloitte and AWS, and they have these like 6 factors, and then on those 6 factors, there's like 5 levels within it. So it's very hand wavy. You can self-score this sort of stuff. There's nothing super technical about this. This whole talk is meant to be quite accessible to the point where it's like I even scored my own personal finance, like what's the maturity model for how I do my own spreadsheets. So a lot of this is meant to be tongue-in-cheek, but you can apply these same things like at a personal level, but also at like a corporate enterprise level. So this is the talk that I'm referencing. So that is Cale, that's my boss. He actually gave a talk here about 3 years ago. Talking about forecasting and time series analysis, really smart dude, and doing really cool things. So this is Nick Hull, who's another one of the partners. I think he has a background in economics. But yeah, it's an hour presentation, and then there's like a white paper to the actual talk if you want to go into more detail. But I'm going to summarize and plagiarize other people's work tonight. Cool. So that's what I'm going to get to. So when I did my extreme spreadsheets talk 2 years ago, this is my data model for my pipeline. So taking my gross income after taxes and then cost of living, but then how do I track all the variable expenses going on in my life? Google Forms and Google Collaboratory. At the time, I didn't go into much detail of how I did it. For a special bonus for this talk, I did create a 20-minute screen share, so you can find that on YouTube if you want more details after the fact. You're welcome. So this talk, there's the main talk, but I've also got a heap of other side quests and Easter eggs that we can talk about later, or you'll find on YouTube later. Cool. So this is where we're going to get to. This is the framework. I'm not going to read all that. That's boring. But this is how I've assessed my personal finances. So I have a complete understanding of the data that I've captured from multiple sources. Cool. I have a firm-wide strategy and ongoing investment in data, but I don't have a dedicated budget. So, okay, well, I'm not at a mastery level then. I do have a data-driven culture dedicated to the data team, me, with high capability. What's my technology? Well, analytics informs my decision making. It's not entirely embedded in every decision I make. I kind of like fast and loose on some decisions. Data is not analysed frequently. It's analysed routinely. There is some data governance, so I can be a bit fast and loose with my own personal data because like close enough, good enough. I do have some investment in the implementation of machine learning. I'm definitely not at the mastery level. And how am I doing that? I'm trying to figure out how much do I spend on groceries. It's a very interesting thing. So I export all my bank statements, and then I try to make a model that'll, based on the transaction text, classify what is my definition of groceries, which is going to be different for guess question.
Have you looked at OCR for receipts so you can get a bit more like lettuce versus...
I know way too much about OCR and I intentionally am not touching that.
Good. Yeah.
Yeah.
I'm thinking about that because I'm looking at my grocery bill at the moment and I'm wondering whether it's the split ice creams or the legs of lamb that are killing me.
So, whilst we're on that tangent, one of the offerings that our Deloitte group is offering, essentially, AWS has Textract, and I should know this. There's 2 machine learning services for like Textract and analyzing the text in it. The sneaky trick is they run it through Textract twice to get more meaningful information for receipts, and then like that is as a service. So if you're just like uploading receipts to an S3 bucket, that'll trigger an event to automatically run that processing. Here's the receipt output, but we try to run it through twice to get like a better output. And then this could be applied to like the insurance industry, where it's like, where's my processing number? So trying to have things that are a more sophisticated question on what is an image. Anyway, tangents. You can do that is the answer. So this is where I'm at with my personal finances. So the point is this framework, you can take this, go to your workplace and go, yeah, where do we sit on that? It's subjective. Measure yourself, but it's also able to highlight where your deficits. So I put on here a pink one, the over-indexed on tech, which is what I see in a lot of companies where they're like, hey, machine learning is cool, let's put a heap into that and a heap into technology and completely miss the people part of it, any sort of strategy, deliberate investment and processes to keep that maintained, because it's like new shiny. So that's where we're going to get to with that. Oh yes, because no data source is ever clean. There's so much work in that. Cool. So this is what we're going to get to. Talk about data pipelines, machine learning as a business tool, not as a shiny sort of thing. Then talk a bit about decision science and finish up with maturity models, and we'll go from there. So any questions at this point? There is a lot of slides I'm going to get through. I'll talk really fast. I'll try to have a sufficient amount of memes too. So data pipelines. If you've ever read the Lean Startup book, this is the summary of the book. You're welcome. Build, measure, learn. So these are the 3 key things, but also sneakily, that is called the scientific method. Most businesses are, and even like these sorts of books, like, hey, here's this cool way of doing things. Measure what you do, then make a new decision, have a new hypothesis, repeat that loop. Science. So anyway, the measure part is your data pipeline in your business. Measure stuff, capture it. Whoops, ran ahead. And then the decision science is once you've got that pipeline, you've got your dashboard, your KPI metrics that are coming up, your big number, make a decision. What are the actions that happen after you've got the information? So these are 2 key things I'm going to be talking about. Also need a drink. So in the work that I do, just about every company we go into, there is some variation of this diagram. Regardless of the data warehouse, if it's Databricks, Redshift, Snowflake, whatever your data lake is, there is some data storage thing where we ingest data from multiple companies, and at the scale that we're operating at for the clients, yes, there is a business, but they tend to acquire other businesses. So all those businesses have their own databases and source systems. So they've probably collected data in different ways, but then you have to conform that into the one data lake, and that's where a lot of my work is. Making sure that it is consistent, and Databricks coined this medallion system of just like, what is the level of maturity as you're transforming the data to be cleaner? At this layer, I've just ingested it, so it's probably just text. At the bronze layer, you probably converted that text to a date, but it's like, is it local time? Is it UTC? I have no idea. I've just converted it into a date, so I can actually do something with that. At the silver layer, that's probably where I've converted it from a bit more business knowledge about, oh yes, it is a date, but it's like, I have to do this little tweak here, or there were these public holidays, or these like daylight savings changes, where it's like to get it all conformed into like UTC, so I can compare across multiple businesses. So that's what's happening at the silver layer. And then it's only really at the gold layer that we have well-formed data models, and that's where business analysts are really like hit their stride about what is well-modeled data in the business, and that's the stuff that gets consumed by dashboards. But now this is the part that I like to have a bit of a rant about. This bit, the air gap in data pipelines. You can have all this amazing sophisticated technology, end of the day, there's a dashboard, someone looking at a screen, and it's like, cool, pretty dashboard, but they're going to just export that to Excel and do their own analysis anyhow. But it's that air gap where people are making decisions. So fancy tech, it means nothing if no one's actually consuming it. That's why if your diagram doesn't have a stick figure, what is the point of the technology that you're building? As technologists, it should benefit someone. Otherwise, it's just cool shiny for the sake of it. So anyway, air gap. So I mentioned earlier I wanted to do data science, wasn't many data science jobs, because there is this. There is so much work in collecting and conforming the data, so I wound up leaning back on my software engineering roots for a while and did a whole lot of data engineering, because that's where most of the work is. And once we've at least made the data available, reliable, and secure, that's where data analysts and business analysts come in, and it's actually probably this ratio of like 3 to 2 on any given project that we're working on. The amount of people that need domain knowledge about the business of what we're trying to model. Do you see a data scientist yet? No. There's this many people involved to just get a data pipeline reliable, accurate, and available, and then the analyst to make it well modeled of what is meaningful, and especially if you've got multiple companies that are getting acquired to conform into that pipeline. Cool. Now, still no data scientist. The ML engineer. So this is where we're seeing, because this is all like business as usual, just get business intelligence, like how do I make decisions of are we still making money? But then we want to do the ML platform, really this is forecasting. I'm trying to make predictions. That's what tangibly machine learning models. I'm trying to model the future a little bit, trying to make an informed decision or predict customer behavior. So this augments your data pipeline. You're trying to take the well-modeled and clean data and feed it back into the system. It's still going to wind up on a dashboard. I would like to give a talk on this. I think this is probably the most exciting thing that's coming in the next year or two. It's been available for at least like 2 years, but it's still a bit immature. Across all the major vendors, if you've deployed your machine learning model to like a SageMaker endpoint or Databricks has their own model serving, you can create what's called an external function in SQL. So you can do select churn and give it a table of data, and it will call out to your model and do like that forecasting of give me a churn score for my customers. So who's most likely to churn? So I can write that in SQL, and then it's up to the ML engineer to make sure that SQL function is reliable. And that's going to make the life of a lot of analysts so much easier and more empowered. That it's like, hey, what I'm already doing to do my analysis, I'm just going to run this extra function across it. I think that's probably the most exciting thing that's coming in this space. But that's my own editorial. Yeah, and this is roughly what it looks like if you're using AWS Athena. Create an external function, you register it and say, hey, look, it's this model over on SageMaker, and then I select predict customer registration. That's cool. That's what gets me excited. Yes, we don't want to solve imaginary scaling issues either. At scale. So, one of my key takeaways is start small, start simple. I was talking to someone earlier so working with Anton at Komatsu, we were trying to do anomaly detection on the mining equipment, and we tried all the fancy methods under the sun. Guess which one won? Linear regression. We had an ensemble of linear regression, and it worked amazingly, like so well. It trained so fast, it was so accurate because the different properties of a mining machine, it's a mechanical system. They all had like linear relationships within each other. So the anomaly detection we're doing, we trained it on only like the last 90 days, which was like summer data. and then you train like a random forest, which it can't extrapolate for data it hasn't seen. So when it gets to winter, it was worse than just like random. So we had all these like fancy machine learning models and not being able to extrapolate. An ensemble of linear regression worked amazingly. So start simple, and then try the higher sophisticated models on top of that to see if they actually do better. And we found that they were actually a lot worse than just like the basic stuff. To our disappointment of wanting to try the new shiny. It's like, it kept proving to us like, no, stay simple. It's like, damn it, life lesson there. But yeah, if you go to the scikit-learn website, major Python machine learning library, right there, the three major ways of doing some sort of machine learning: classification, regression, and clustering. So if you've never seen any of this before, this is probably, actually if you have seen this before, this is probably like a first year data science class, so sorry for repeating myself, but it's important to make this accessible for people that have not seen this before. So regression, if you've ever gone into Excel and done like a line of best fit, that's linear regression. And it's just like, predict what would happen further. So if I had a data set of houses, that it's like how many bedrooms, the square meterage, I could probably predict a price based off that. It'd be a more sophisticated model if I added postcode, but also time, like year and month, because like seasonal changes in the market. So that would be a more sophisticated model by adding more features. But regression, I'm predicting a number. Sometimes, so a startup I worked at, we're trying to predict churn. So we had a whole history of all of our customers, the ones that renewed their subscriptions and didn't renew their subscription. So based on that, we were trying to predict, of the customers that are active, what's their likelihood, based on all these features, are they going to churn? We had interventions after that to say, hey, look, we noticed you weren't active on your account, or would you like to have a discount? And we had churn change from like 30-something% to like 18%. That's just money made just from that model, like trying to, hey, would you like a discount? And they didn't churn. So tangible business results just by having a prediction of a number and scoring people. Saying like, if anyone's ever had like an Audible subscription and tried to cancel out of that, the 18 different ways they try to get you to not cancel, that's what they're doing. Classification, some of the key things is trying to detect fraud. Spam is a pretty well solved thing at this point, but trying to detect fraudulent transactions, or in the insurance industry, a fun story where I heard there's a group of 18 people all working to get subsets of 3 people to work on fraudulent, so someone's the complaint, someone's the victim, and then someone's the witness, and they all take turns. But trying to figure out that network of 18 people of how they're all colluding was apparently quite interesting. But anyway, detecting fraud. Is this fraudulent, or is it like a legit transaction? Again, preventing fraud saves money. And that is a very important business value to justify why you would want that sort of model. Oops, clustering. Again, I did this at a startup that we were working at, where we looked at all the customer data and said, without any labels, cluster them. Naturally, what patterns do people fit into? So we had a group of people that when we looked at the data, oh, these clearly look like power users, or these people clearly look like they're seasonal. These people are clearly not paying anything, but they are abusing the system to the nth degree. They're the freeloaders. So just by looking at that data, I've now got labels based on those cluster features. I've just turned that into a classification problem. So I've seeded a classification thing where as new customers come on and exhibit certain behavior, I can try and classify, are you a power user, are you a freeloader, are you a seasonal person, are you likely to churn? So this is having like segments and personas in your customer base, being able to have specific interventions of like, oh hey, we notice you don't specifically call them out as freeloaders, but we see that you're highly invested in our platform and see value in it. Would you like to pay for it maybe? Instant time series modeling. Start with ARIMA. This is the linear regression for time series. And then Saramax is, so I'm just going to glaze over this. ARIMA, if you want to model things that oscillate on like a daily and weekly basis. Saramax, if you want to look at things that also oscillate on like a monthly and annual basis. And I think the X stands for extraneous variables, where you can give it a time series and you tell it what days are public holidays. So it de-weights those days if they're a bit weird. So what happens in these ARIMA models, you can see the top row is the original signal, and then it's decomposed into these three components of like, what is the seasonal, the oscillating part, what's the trend of like how it's like ramping up, and then just like other random noise. So they're the three parts that I can decompose it out to. This chart here is real temperature sensor data from my house when I was trying to keep bonsai plants alive, and I killed 4 of them. But you can also see the power went out, so there was a gap in my data. But the ARIMA model is able to go back and impute and infer what that should have been, and then it's also forecasting what it thinks the future temperature data should be, and that big red is its uncertainty. So, you know, weather forecasting, it's this cone of uncertainty the further out into the future you're trying to predict, and that's why there's only like 3-5 day weather forecasts. The closer to now, you're better able to predict. The further out into the future, stuff can happen, like COVID. So yeah, start with those, and then there's fancy deep learning models that you can do on top of that. These are surprisingly good with IoT. If you want to get deeper into it, good book, Practical Time Series Analysis by Eileen Nielsen. My head's in front of the book. So that covers both R and Python code, and there's a data camp course, ARIMA models in Python. It's really good. Cool. Decision science. I need to make a fast click with this. So, bit of cognitive science and how we make decisions. These are data points. Just data. Whether it's true or not, don't know. We've just collected this data. It could be false information, but it's just data. Then we apply the lens of our values on that data, whether something is good or bad, whether we think it's a benefit or a cost. Then some things are actually more important than others, so we assign weights to what is a pro or con in making a decision. Context matters. So in times of stress, the emotional weighting when stressed out, or timelines like deadlines or budget constraints, or the government rolls out a new policy where it's like, oh, funding's been cut, oh crap. I might actually make a different decision if I am stressed. So it's interesting to think about our decisions under that light. Would I still make the same decision in a high stress situation? So this is a thing called decisional balance. So I've recently got an ADHD diagnosis, and I've recently learned that what we do when we make these decisions, we have 7 executive functions, and we put our decisions through each of these executive functions. I'll get to one of them later. But if you've got ADHD, these executive functions don't work all the time reliably like neurotypical folks. So that's fun, trying to make decisions when you can't trust yourself as well. Cool. So, trying to make good decisions. So this is the classic truth table, confusion matrix, whatever it's called. So we want to make all the true positives and true negatives. So it's like making a prediction and it is actually true. What we're trying to avoid are the type 1 and type 2 errors, because the cost of consequence that's associated with it. So if there is a bank transaction that is about to go through, but I hold it up because I think it's fraudulent, but it's not, what's the actual cost of that? Oh, the customer's inconvenienced for a little bit. The type 2 error, where it's like, I did not detect it, and it was a fraudulent transaction, and we just let that go, the customer's materially infected. What's the cost of consequence for making bad decisions? Bad predictions. So whether people or machine learning models making decisions, that's the lens that we need to think about when our models don't work. A really good book is Cathy O'Neill's Weapons of Math Destruction. It's been out for about 10 years, but really good case studies talking about exactly this. What's the cost of consequence? And in particular, the legal system. The cost of finding guilty for a person that is not guilty. So that's a type 2 error, what is it? False negative. So when we as a society decide that someone is guilty beyond reasonable doubt, because the cost of putting a person that is not guilty away in prison that is guilty, the cost to society, we decided that is too high. We would rather err on the side of someone that is guilty, but we can't prove it, release them back into society, because that is the lesser cost. Both not great outcomes, but that is the lesser cost. And that's how we've biased that decision process, because that is the greater good for the cost of those consequences. Most people in this room, I hope, aren't making decisions at that level of magnitude of consequence to people, but let's be mindful about what we are building leads towards decisions that do have material consequences, especially if it's things like, home loans is a classic one, where it's like preventing someone from having a financial instrument where they can invest in themselves and their future. Preventing job applications are huge costs to people and their lives and the trajectory of where they can go. So think about consequences with the decisions that we make. Cool. So this is one of the things I was going to talk about, where this is one of our 7 executive functions. Being able to simulate the future and think through like thought experiments, mental playgrounds. So if I did make this machine learning model and I am trying to predict something in a shiny dashboard, before, like, I've had this conversation with a stakeholder or someone in the C-suite, what was going to be months worth of work just to make a dashboard, not even a machine learning model. If I get this information for you, what action would you make? Oh, it'd just be interesting. So you're not actually going to action it. So if you see any dips or step jumps in it, or if it's ramping up or down, that materially makes no difference. You would make no action upon that. No. Yeah, we probably shouldn't do that. Yeah, no, we're not doing that. So these are the sort of things that when you're looking at what should I see in the data if I apply a marketing campaign. So this is that build, measure, learn. I built the thing, I want to put it out there, I should see a result. Or if it's like business as usual and I see spikes in the data or dips in the data, was that a public holiday? Did a server go down? Like, that's an anomaly that I should probably investigate. If there's a step jump because there was a sale, there's a marketing campaign, cool, that's normal. If there's a drop in sales because servers went down, all right, we probably want to keep an eye on those sorts of things. So if this happens, then there is an action. So we can think about these things and have a contingency plan. So almost like a fire drill, like what is that decision? We know in advance what the decision and action is going to be. Rather than be like, oh no, we see the data, what do we do? You can think about that in advance. Cool.
Can I ask a quick question?
Yeah, sure.
Do you think we're a peak dashboard?
Sorry?
Do you think we're a peak dashboard? As in, do you think the number of dashboards we've currently created is the peak, or we've got more to go?
Are we at peak dashboard? I don't think we've even come close to peak dashboard. The amount of like nested exploding pie charts with 3D rotations, oh, we haven't seen the extent yet.
So second follow-up question. Do you think in the dashboard process, which we were just talking about then, that there should be automated coded responses to certain signals that you see in those dashboards? Do they already exist?
Yes. So with dashboards and being able to have those signals and automated decisions, yes, there are already situations where, actually, Amazon Redshift, they monitor a lot of symptoms about the database, about how fragmented it gets, and they use machine learning to predict, all right, am I seeing a certain symptom? And they automatically apply optimizations to the database. So there's like 12 different things that they're already monitoring, making actions where a database administrator would normally have to go in and click a button, but they're just like, most people just do it, so we're just going to do it for you. If you want to stop that, you can go turn it off. So it's opt out at this point. But that's kind of cool where they're automating some of those decisions because the cost of that decision isn't that big of a deal. So they can just like automate that decision. So a lot of that is happening. What is scary is if that is applied to any sort of like weapon, like defense. Oh, hey, we detect that another nation state is firing missiles at us. We should definitely launch our rockets at that. And it's like, oh no, it was a civilian plane. Like those sort of automated decisions, what's the cost of that consequence of that decision? Probably want to have a human in the loop for that decision. Cool, but speaking of defense, capability maturity models, this is a thing. I actually learnt this when I was working at BAE Systems. A senior engineer was explaining this to me. So when you're offering a capability, a service, this is like 5 degrees of how to measure that. So step 1, it's like almost like straight out of high school. I've got just a general understanding of the world. I don't know how to do stuff. I'm going to have a crack at it. Level 2, I've been doing it for a while. I might write that down, share the process with other people. It's only at step 4, I actually have metrics to measure what is quality. And then it's at step 5 that you're trying to minimize failures and minimize cost, as well as maximizing your quality. So this is just a capability maturity model, which has been around since the 80s. So this is why I've been like in the background, been thinking about this for a while. And whenever I've come into companies that they've got their own, trying to build a data platform, I've been already thinking about what's their, my lens of what's their maturity and where are they up to. And it's like, I wanted to work in data science and machine learning, but it's like, they're probably only still at level 2 or 3 with their maturity of being able to collect data. It's like, machine learning is like down here at 5. So it's like, most of the work is like data engineering at these levels 3 and 4. That same engineer that was showing this to me was saying that there's also a tongue-in-cheek, the immaturity models. And I'm sure that we've all worked at these sorts of institutions where, the processes, however inappropriate or ineffective, are implemented with rigor and tend to obstruct work. And then it gets to the point where it's like, they're committed to ineffective processes. And then -3, they're scaling. They work to downplay and sabotage the efforts of rival organizations and departments. They're so good at screwing up their own stuff. Everyone needs to learn that. So yeah. We get into the tail end of this. I'm almost done. Data and analytics models. So for 2018, the Linear Digressions podcast, who are also consultants, they had this white paper where they were talking about analytics models, and this is what the lens of how they're analysing clients, where they're going in to assess where clients are at and figure out what the deficits are, to how can we like work on that to build everyone up together. So if you want the links to the podcast, the white paper, you can go have a look at it. So they've got 5 axes and then like 4 levels. So this is pretty similar to the one that Deloitte and AWS has put together, where it's like there's a few different dimensions and a bit of a scale to it. So if we jump ahead, again, webinar, jumped ahead. So it's these 6 dimensions with 5 levels. So starting at like basic, you just like, I'm not even trying. I've almost got like a box of receipts at best under my bed. That's like the most basic level. And I have no idea like whether the receipts are mine. Jumped into the meme. So mastery is like having a complete understanding, multiple sources, firm-wide dedicated budget, data-driven culture, and strong governance policies. I think so in the over-indexed tech, and this is where we see a lot of companies that have deficits, there's a lack of strategy, people, and processes. So in the webinar, the thing I'm going to summarize are the key findings of those 3 axes. Because not many people care about the quality of the data, and that materially impacts the machine learning budget. Cool. So in the strategy area, so the report covers like 500 companies in the APAC region, where they surveyed them over like a couple of years, and being able to progress from one level of maturity to the next, I think it was like 8% increase in revenue on average. And when you're running billion-dollar companies, that's sizable. But what those companies exhibited to be able to move up those tiers, having top-down leadership, because it's like a lot of those decisions start at the top, and having the funding and being able to guide the ship to where it needs to get to. Also taking pilot stages, so almost like how you've got like angel investors and Series A investors, having that incremental investment in your own projects. Take on risk slowly, have key outcomes, and measure what you're building. So strategy. Sometimes strategy is just corporate theatre and people just do it for show. People, because all this is for nothing if you don't have the right people, the right skills to make it happen. My own editorial is that emotional intelligence is going to be a game changer. If companies don't have emotional intelligence to actually create safe spaces, a lot of traditional workplaces are just going to not have talent and naturally die as they should. But still, having skills, I've seen situations where there's been hiring freezes, but we still need that skill set to deliver. So we had internal initiatives. If we can't hire, we'll grow. So we built our own internal training courses to make people close that skills gap. So that's one way of going about that. But also role models. If there's no one in the position for the career ladder where you're wanting to go, no one wants to be the first person to make that, like cut down the lantana through the jungle of corporate bullshit to try and get there. No one wants that. So this is the last one, process. Two key things in that webinar were about governance, and I think I was talking to someone earlier about this, the game-changing thing in data and decisions, governance. Cybersecurity, the different types of data. When I was working in defense, anything that was like secret or like not public knowledge, you just treat it like asbestos. No one wants to go anywhere near that, and it's like it's specialized people, and you do it deliberately, and then you get the hell out of it. It's like you want to deal with like just public data only. If it's secret, it's like, oh my God, I'm not touching that. Specialist people. But also it requires a high degree of skill to work in this area. Where's that skill come from? There was a long lead time to get those sorts of skills to make sure we're treating data properly, or we wind up seeing what we see in the news, which is not where data should be, leaks. But yeah, cataloging and lineage, because people have the right to be forgotten. So if you're trying to figure out where do they exist in your entire data pipeline, you're like, I don't know where all their data is. That's problematic. So understanding where all your data is. Cool. So where we were getting to is there is a data analytics maturity model. You can score yourself. Here are the resources. Thank you. Any questions?
Yeah, I was wondering, for the decision making, especially in the sectors that you're seeing, like the legal system, like with loans, to what extent do you think will be automated? Because when I was looking at one of the first slides that you had, or the main pillars of decision science, I thought, well, like ML algorithms tend to be pretty bad at picking up context.
Sorry, I don't understand the question.
The question is, to what extent do you think that the decision-making process will be automated in things like the legal system?
They've tried that before. There was they trialled a machine learning one. I can't remember the location, spaces case study I did a couple of years ago. I think it was in Seattle, and they were looking at convicting people or police patrols and actually arresting people based on a machine learning model. And they found that obviously the data available to train the model was very racist. And so they just ended up arresting and trying to charge people or preemptively predict a crime. I'm pretty sure there's a million sci-fi movies on this, but they did actually try that. So I think some people have learned from that, and I don't think there are many more important decisions about that where there's going to be that collateral outcome, but that's just my experience with that.
Recommend reading this book, audiobook, if you struggle to read paperbacks. Yeah, essentially it's a whole heap of case studies, and I'm pretty sure they talk about that example where any sort of scoring system, depending what you've trained it upon, high likelihood human history is ugly. And if we train it to predict and reinforce future behavior based on ugly behavior, we're going to get more of the same. So it's like, yeah, how do we prevent those feedback loops of having a detrimental society? So understanding what features are going into it and explainability is probably a good start, because the consequence of poor decisions aren't great. I doubt there will be automation in so personal opinion, this is my opinion, I don't represent Deloitte. Legal, health, insurance is intrinsically linked to health as well, because they're essentially trying to model risk around it, or health insurance in particular. That'll be some of the last industries to automate because the cost of getting that wrong is way too high. So they would be quite conservative, I'd imagine. Good question though. Oh yeah, liability of decisions. The classic ones like the Tesla, where it's like, it's making a decision to either do I speed up for that cyclist or do I try to avoid hitting them, sort of thing. It was like, because it came out of nowhere, sort of thing, around a corner, and it's just like, I don't have enough information, so it's like, yep, carry on, bang.
I've been looking at, like last couple of weeks, how do I use artificial intelligence to improve my ability to do security consulting? And the answer is that I should not. It's just taken me a few weeks of being like, oh, it sounds really cool. Wait, I'm going to be exposing information that is sensitive to like language models. This is a bad idea. Oh, I'm legally liable for hallucinated content. That is a bad idea. And so,
Yeah.
I feel like if you're in professional services where you're out to actually give a professional opinion about something, you're probably not going to have your like stuff automated by either AI or ML models anytime soon.
Yeah, provenance of where data exists. So if you're sending it off to ChatGPT, it's like, you've sent someone's data somewhere else. Like, what are the compliance reasons about that? So it's like, we've had clients where, for compliance reasons, the data has to stay in Australia. Even if you have a separate laptop and you remotely view it in another country, you're viewing that data. It's existed on a screen in another country. So no, you can't even remote desktop from another country to look at that data. Yeah.
I was looking at like GitHub Copilot chat.
Yeah.
So I can interrogate source code locally, and so I'd say like, oh, let's look at the Git history so I can identify developers that are at risk, right? And I was like, wait a second, how does GitHub Copilot chat work? Oh, it ships it all off to Microsoft in America. I
Yeah.
don't think ASD would like that. So,
No.
and then I was like, wow, it's very expensive to run AI models on my little MacBook. So guess what? I guess I'm not going to be using this tech anytime soon.
Yeah. What's interesting when you look at, again, side tangent, if you look at GitHub or Git repositories and like what people talk to each other, it's a thing called Conway's law. It's like the code in a repository and in software architecture reflects the organizational structure of who talks to who in an organization. So if there's infighting, you can definitely tell people don't develop together. So you can see that in code, which is interesting. Yeah.
So you studied, the hardest career in the century or whatever.
Yeah.
In data science, but you find yourself being a data engineer, which is like plumbing.
Yep.
How do you find it? Like in the actual, moving from what that bright shiny lights to moving data around?
Grateful to have work, grateful to have income, because it's such an emerging space, especially in Newcastle. There just wasn't many jobs around. So actually a pandemic was quite helpful for me because suddenly all jobs were remote. So I had access to the cost of finding any job became a lot smaller for me. So geography was no longer an issue. So trying to find work locally was always an issue. I think I joked around before that it's like my career swapping every year or two, it almost looked like I was a consultant to these people. But that was because these projects were a whole lot of capital expense. We need to build the platform, then we don't need as many people to maintain it. So that's why I find myself in consulting, because the nature of our work is doing that capital expense to build up a platform, and then you don't need as many people to maintain it. So that works out well for me for having job security. But yeah, a lot of the work that we're seeing when people are hiring the consultants to build the thing, it's data engineering, because they've hired a data scientist, they want to do the fun work, but it's like where the bulk of the work is, well, I'm doing, essentially it's software engineering with specialized flavors, data, and then, so software engineering and DevOps, it's like, how do we deploy code? Data ops, how do we make sure that data is reliable in production? ML ops, how do we make sure that machine learning models are reliable? Reliability. It's the same pattern, but it's just like 3 different assets that we're deploying. So yeah, I like having a job is the answer.
I think data pipelines, and obviously your clients always break them, so you'll never be out of work. Right? Like, it's always being a mechanic for an unreliable brand of car.
Also, what platforms I'm working on, I was telling someone earlier, it's like I work on clients for every 6 to 9 months. And then by the time I finish on one client with a different tech stack, say we're doing Databricks or something like that, and then the next client we're back on Redshift. It's like what's happened to the ecosystem in the last 6 months of new features that have come out? It's like, oh my God, I had to retrain. Just gone from client to client just to stay on top of that stuff. So most things I know in tech, I just assume there's like a 5-year half-life for that knowledge of like, it's probably going to be superseded by something which gives an order of magnitude improvement. So the cost of doing something, I don't need to know this way because there's a much better way probably in about 5 years time. And we try to tell clients like, whatever you're building now, good chance in about 5 years time, you'll be like, ooh, new shiny. And you'll probably want to swap that over with something else. Questions?
You mentioned like the maturity model improves revenue for like companies. Are they
Not a causal relationship.
But so if you want to suggest to your client to improve a maturity model on their data pipeline,
Yep.
Apart from the revenue, are there any other tools you can use to influence them, or like any other ideas you can give them to influence them to improve the maturity model?
Good question. I don't know. Because again, I'm just like, my boss put this presentation out, this report, I've read what they've done, and it's like, I haven't read deep enough to be able to answer that question, sorry. Essentially, the gist that I got from what they're saying is like, identify what your deficits are, try to work on them, get your maturity model up. As a side effect, you'll probably improve revenue because you've got more mature processes. It's a lower cost of doing business, and you probably reduced your failure rates of delivering quality. It's kind of simple, but sometimes it needs to be spelled out. It's like, oh yeah, we should just focus on those things. Do simple right. There was a question over here, I think. Nope. Just going to make someone ask a question. Plus, we're getting close to pub time and probably want to wrap up.
One question. Yeah. How do I learn data engineering? Because there's no jobs in data science, right? So just preparing for the future.
And there's a degree in data engineering.
Where at? Oh, there isn't? Oh, okay.
There's always this peak, like there's a peak of data scientists, and then when the peak went down, the uni's caught up, and I think there's a peak of data engineers, and then as soon as they'll start going down, the uni's like, that's
We'll see that with
it's always there.
I think what I'm seeing is between traditional disciplines, there's like the gap or the overlap in those skill sets winds up becoming a new role. So you've got like software engineers and data scientists. So it's like, well, that bit in between is data engineering. So it's like, you can have people coming from both sides where it's like, I've got a traditional like statistics background. I care about data deeply, but how do I deploy that? Well, I probably need to work on my software engineering skills. Or if I've got software engineering skills and I want to work adjacent to data scientists, I should probably understand how machine learning models and data quality are. So it's like ramp up and close the gap and meet in the middle of what these new hybrid roles are. They're between two different traditional roles and close that gap. That's how I looked at it. Cool.
Just want to add a little bit. Probably you can start one platform. So let's say you want to use AWS, like cloud computing platform, and then AWS or Azure.
Yep.
And then from there you can learn quick private around data lake or ADF or data factory if you use Azure.
Yep.
Or Synapses, and then from there just pick up the pieces bit by bit, and there will be like learning curve, of course. You will keep the world many times, but get there. And
Yeah, I agree. I look at a lot of software engineering is almost like music theory, and then it's like every 5 years I need to learn a new instrument, but the music theory is still the same. So it's like if I'm going from one cloud platform, they've got storage, they've got Spark, they've got the equivalent. So if I'm going from what I know on AWS, it's probably just like, oh, they've just got a different name for the exact same concept on this platform.
Yeah, because for me, I'm not so worried about the software engineering stuff, and I have actually got a hybrid role now. If I think about it,
Yep.
Application security is literally application development security, right?
Yep.
So it kind of makes sense that analogy is his name. I was more worried about the data part, right? Because I can go read a spec and do it, so learn Databricks, right? But I'm not sure about what is linear regression.
The way I looked at like a university degree, every semester you do 4 subjects and each subject has a textbook. They get you to read 80% of that textbook, and then they hopefully you can get above 80% on what you've read and understood out of that. So I just constantly read. So I don't do 8 textbooks a year, but I try to do like 2 or 3 just to try and stay on top of what is industry, what is new. And then you can almost create your own syllabus of like, what are my skills deficits? What do I want to bridge? There is probably a book on the topic. Go and learn that, practically do it. Yeah, lots of reading and essentially create your own syllabus, your own micro credentials of just learning and understanding. Cool. Let's go to the pub.
All right, thanks everyone.
Thanks everyone.
Thanks Josh.